one of them back up to me.
Yeah, it's okay. Yeah. It's good afternoon. This is a chemistry session. Chemistry tutorial rather. So raise the board. Good afternoon once again. We'll do quite a lot of things today. First of all, I'll start looking at test 1. I'll look at first questions of test 1. We'll go through. Then we'll be able to look at other things like tutorial sheet 5 and the other arrangements. So I'll say CHE111 test 1 revision. Okay, CHE111 test 1 revision. Yes, okay, that's better. CHE111 test 1 revision. So the first question they asked you about how to determine the significant figures. So here you are the 1,000, or you are the 150,000. Then you are taught to write the scientific notation to 4 significant figures. So here what we are saying, this one, you can just say 1.5. So if your answer was 1.500 times 10 to the power 8, this would have been correct and you'd have accumulated 1 mark. So that was the question there, that was the answer. Then the other one, you are the, this is A, then B, you are the 2, which is a 234,555,359. Then they said to 3 significant figures. So here what you are supposed to say, just give us 253,000,000. That would have earned you 1 mark. So these were values that were supposed to be given on that particular day. Then you have C, where we are saying you have a situation. We have 536 times 0.330160. Or then also multiplied by 6.0002, then divided by 0.0048 times 1.1. Okay, so when you are given such a situation, you need to solve. So that you come up with the final value. You come up with the final answer, then you are able to give us the answer. Okay, so if you evaluate this one, if you evaluated and your answer, you had something like 118,000, like 87288.7 37838. So when you have this figure, we did the calculations. When you have this figure, the answer, at least we expected you, when you evaluate this one, your answer should have given you should have given you something like a 1.8 times 10 to the power 5, which would have earned you 1.5 marks. So if you did this, then you're well and set. Your answer was correct. Let's move on to the third one, which is C, then 2. Okay, so that we are able to see what transpired. So you need to be preparing for your test 2. The test 2 is also on your way. So you are the 0.0417 plus 0.956 rather plus 0.0022954. Yeah, then you are told to sum up all this. Of course, in chemistry, we are also trying to find the total value. Of course, just like in mathematics, we are also wanting to find the total value of the figures that we have. So in this case, when we summed up, if you summed up, it should have given you something of this nature, which is 1.00 or simply 1. So this one would have earned you 1.5 marks. So that is the thing. Then the other one, question 2. Question 2, of course, we have always been talking about this. Finding the average atomic mass. Of course, the formula. Average atomic mass. Atomic mass, of course, depending on how many isotopes. Depending on how many isotopes you have, your formula will correspond. If you have got 2 isotopes, of course. Now in this case, question A2 in your test 1, you had how many isotopes? They were saying of these isotopes, that is element X, which was not known, which you were supposed to find. Once you find the average atomic mass, then you'd have gotten the element. That element you'd have gotten it on the periodic table, just simply comparing your value as to that that is on the periodic table. So you just say, so you had a table. So let me just erase on top so that you are able to get it. You had a table. You just get another marker. Just a moment. So that you are the table. You are the table. The table was there. Okay? You are the table. In this table, you are the isotope mass. Then you also have the relative percentage abundance. Okay, you had that one. Then of course you had 3, which is 24.0. Then you also had the percentage. Mind you, these are in what? Percentages. So you need to take note. 64.2. Then you had 20.3. Then you had 15.5. Then 26.0. Then 25.0. Yes. So this was the table that you had. This was the table that you had. So in this case, you are going to say there were 3. So you are going to say M1 times the abundance plus M2 times the abundance, which is the abundance percentage, then M3 times the abundance percentage over 100. So once you have that one, this one now is a matter of you to replace. There's nothing complicated, It's a matter of you to replace and ensure that you have gotten the correct values that you are substituting. Okay, so in this case, M1, where is M1? M1, you have got this one, which is what? 24.0. times what is its abundance, which is what? 64.0.1 rather, 0.2 rather. Then, of course, plus M2, which is what? 25, isn't it? 25.0 times the abundance, which is what? 20.3% plus M3, you know it is what? 26.0 times 15.5, of course, percentage over 100. In this case, if you did your calculations well, it should give you 244, okay, as your total sum of everything on top, okay? Then over 100, of course. So this one will give you how much? Will give you 24.49, something like this, isn't it? Grams per mole. Okay, grams per mole. Now, after evaluating such a way, after making such an evaluation, you need to understand now, you need to compare on the periodic table. Is it tallying? What element is it? So from the calculations that you would have made, using the periodic table, this one is magnesium. So magnesium, which has got relative atomic mass of almost 24. So this one should have been an easy task, magnesium. So if you got magnesium, this question was carrying, I think the entire question was carrying 5 marks. 5 marks. This entire question was carrying 5 marks, which was supposed to be gotten. Okay, so let's look at another question and we see what it transpired. So we are going to look at A3. So this one was A2 rather, which is 2. This one was A2. Yeah, this one was A2. Okay, we'll go to now to A3. So A3 we'll see and we'll appreciate what would have transpired. Then you'll be able to get it from there. So ensure that as we are going through those, if you remember you had made a mistake, and now you need to do the right thing, probably in the exam, which will be coming shortly, that is in December. You need to be ready for that one, so that at the end of the day, you clear CH111. So we look at A3, so we are going to go at A3. A3, what do they want? Which is A3. Let's look at A3. What do they want? They said A3, sulfuric acid is a white solid used by plumbers as a lime scale remover. Okay, a sulfuric acid contains 14. So let's list them down. So 14%, 42% of what? And nitrogen. Okay. Then it consists of 3.09% of hydrogen. Then lastly, it consists of 33.06% of sulfur. Then they are saying the remainder. So as you know, the total percentage should add up to 100. The total percentage should add up to 100. The total percentage should add up to 100. So in this case, you have this. So what you're going to do is you're going to, if you want the percentage for what? Oxygen. Percentage for oxygen. So you're going to say 100%. 100% minus brackets 14.49%, 42% plus 3.09% plus 33.06%. So in this case, you need to have something of this nature, which is 49.43%. That is the composition for what? Oxygen. So after obtaining, now we have, so oxygen we have now, in terms of the percentage, which is how much? 49.43%. So summing up, so oxygen, this is oxygen. Okay, sorry, let me just put oxygen. So summing up all this, it will lead us to what? 100. So now we can continue calculating. So what are we looking for? We are looking for calculation of the empirical formula. So we can erase this part. We now have this one. As you all know, there are a few steps on finding the empirical formula. There are very few steps which cannot complicate things. So you have the N, H, S, O, okay? Then you pick now your percentages. You pick your percentages. As you pick your percentages, you write them like that. So 42%, the hydrogen, you know, it is 3.09, just like that. The sulfur, which is how much? Which is 33.06. Then the oxygen, which would have calculated from the entire 100, which is not complicated. So we are going to say 49.43. Okay? So now, you know now, at this stage, you divide them with their relative atomic masses. Then that. So, you know, for nitrogen, it's 14. So you say 14 brackets, which is 14.01. Then here as well, you divide, which is 1.0. We use those, we have not rounded off. So you have that one, then you have 32.07, then you have 16.0. Okay? So upon this stage, we can shift. We can say, okay, I'll put them like that. Okay? So let me just, so you have reached at this stage. You are now dividing. You need to divide. So this one, how much is it going to give us? It is going to give us 1.0293. Then you have 3.0594. Then, of course, you have that one. Of course, you have got that one. Then you have got there 1.03087. Then you have got lastly, you have got down there, you have got 3.0894. Since you have gotten this one, now you look at the list. Which one is smaller? So you are going to say 1.02. You divide throughout. So 0.293. Then over 1.0293. Then over 1.093. So you have that one now. Okay. So after having that one, so just forgot the 2 there. So after having this one now, the values can reflect. Okay, the values can reflect. So what you're going to have, you're now going to pick up the ratios. It's also about the ratios. So the ratios now will be 1, 2.94, okay, 1, then 3, okay. So we have this one. Of course, this one is 3. So you have this representation. H, then hydrogen, which one? You have S, then oxygen there. So have you seen the representations now? Okay? Okay? The representations now. Have you seen? So these are the representations. So you are going to say, these are the representations now. So, in this case, you are going to say NH3SO3. So this should have been your answer. This should have been your answer where nitrogen, 3 hydrogens, a single sulfur, then 3 of oxygen. Then in that case, you would have gotten it. So there's nothing complicated about everything. Okay? So next week we'll also come and continue. I'll switch now to tutorial sheet 5. I'll switch. So next week we'll be ongoing revising. Then it will be in the first few minutes we'll be revising test 1. Then we'll also be looking at other tutorials. So the preparation now is based for test 2 and that of the exam. So I'm switching. I'm going to tutorial sheet 5 now. I'm going to tutorial sheet 5. So we'll look at, let me just write them down so that people are able to see. We'll say CH111 T5 now. We'll look at, is it visible? Okay. Okay. Let me just go down. CH11 T5. CH11T5. So tutorial sheet 5. So tutorial sheet 5. I'll look at those critical questions. I'll start from question 14 up to question 18, so that you are able to get, because they are starting from the first questions. They were more like a revision to a repetition to the tutorial sheet 4, where we had how to write electron configurations and the like. So let's look at question 14, that is tutorial sheet 5. So I'll look at Q14. Q14. Question 14. They wanted you to find the temperature and you convert it in degrees Celsius. So you had they gave you something like 101.3 kPa, which is equals to 1 atmosphere. Okay. So now we are converting. So you know, this is a conversion which has to be known. This is a conversion which has to be known. So without knowing this conversion, you can solve question 14. So then we are given the 143 kPa. So we need to convert this one. So this one equals to X. So we need to know. So we need to know this one into there. So therefore our X should give us 1.41 atmosphere. Okay. Then you know how to calculate the other consideration is the ideal gas law, which is equals to PV is equals to nRT. Okay, PV is equals to nRT. You need to know that. Okay, you need to know that. So now you're going to solve. You're going to say. So after you have done the conversions, you're going to say PV is equals to nRT. What you are looking for is the temperature. So you change the subject of the temperature, you change the subject of the formula, sorry. So I'm going to say T is equals to what? PV is equals to nR. Okay, so PV, what's the temperature? What is the pressure, which is 1.41 atmosphere? Times you are given the volume. The volume you are given, which is how much? 1 liter. You are given the volume, which is 1 liter. So in this case, you are going to substitute. You are going to say 1.00 liter brackets over the R constant changes depending on the pressure at which you are working, because you have the R constant when you are working with the atmospheres. You have got the R constant when you are working with the millimeter mercury. You have got the R constant when you are working with the pascals. So you need to be able to differentiate. You need to be able to differentiate so that you are able to pick it. So from there, it is now number of moles you are given. So you have 2.49 mole brackets. Of course, the R that we use will say 0.0821 L atmosphere more Kelvin. Okay. So once you reach at this level, you're as good as that. Once you reach at this level, you're as good as that. So the answer should be how much? It gives us 6.90 Kelvin. But this is the answer. But we are told to find the answer in what? Degrees Celsius. Okay? So, of course, we'll say, as you all know, for us to find we add the 273 degrees, okay, plus what we have been given, okay. So I can just say given temperature, Kelvin, okay. So in this case, what you are going to do, since you have got this one, okay, since you have got this one, so what you are going to say is you have got this one. So you say converting K in degrees Celsius. So you are going to just say 6.90 K 273 should be a negative 266 degrees Celsius. So once you have that, then you have gotten it. Okay? So that is the case. Then let's go to question 5. Question 5, question 15 rather. Question 15. Question 15. Let's go to question 15. Question 15 now. Question 15. Question 15 now. Question 15. So now we are going to look at question 15 now. Okay, question 15. Yeah. So question 15. Question 15 now. Question 15. Question 15, they are also looking at now the pressure. So we are still on the ideal, we are still on the PV is equals to nRT. Okay. We are still looking at the PV is equals to nRT. Okay. So from there now, we are going to say you need the number of moles. You know, you need to have the temperature. So what you are going to so you need to list what you want. So the pressure we don't know. We don't know the pressure. We don't know, but the volume we know, which is 5 liter. Number of moles we know. We need to calculate. So number of moles. If you are attending my classes, most cases, I was giving this triangle, which is very much important, which can help you to solve a lot of problems once you face them. So here we were given the gas in particular, which is what? Carbon dioxide. And the mass was how much? The mass was 1.28 grams. Okay. Of course, now we need to say mass of CO2 is equals to what? The number of moles rather. Number of moles, so we can say 1.28 grams divided by, as you all know, it's 44. If you want 44.00 grams. This is carbon dioxide. So then we have that one. Okay, we have that one. So that's the thing. Yes. So we have that one. So now since we have that one, okay, since we have that one now, we can divide. So this one should give us 0.29089 more carbon dioxide. Okay, so you have that one. You now substitute, so you have 0.29089 more of what? Carbon dioxide. So since you have that one, now the R, since we are working with the atmosphere, so we are going to have 0.0821 liter atmosphere more Kelvin. Okay. So then temperature, of course, we have 35.1 degrees Celsius, which is equivalent to 3.08.1 Kelvin. So we have everything now. We have everything at our disposal. Now it's a matter of solving. It's a matter of solving and coming up with the values that would make much sense. So we move. Of course, we are looking for pressure. We are looking for pressure. So in this case, we are going to say P is equals to nRT over V. Okay? P is equals to nRT over V. So in this case, what is our number of moles? We have, which is 0.290849 more. Okay? Then our R, as usual, we substitute. We have 0.0821 liter atmosphere per mole Kelvin, of course. Then the temperature, of course, the temperature is how much? 308.1 Kelvin divided by divided by how much? What is the volume? Which is 5 liter. Which is 5 liter. Which is 5 liter. So upon evaluating everything, we should be getting 1.47 atm. This is the correct value. It's 1.4 atm. That is the pressure that they require on the ideal gas law. So yeah. Then we look at question 16. We look at question 16. Look at question 16 now. We look at question 16. Look at question 16 now. Let's look at question 16. What are they looking for? Here, question 16, they are looking for the volume. We are still on so Q16. So question 16. So you have been given now, this time we are dealing with the pressure in millimeter mercury. So we have got P is equals to 694 millimeter Hg. Okay, then we have also volume, which we don't have, sorry. Then R, of course, R this time will change because we are dealing with pressure in millimeter mercury. So we have 62.4 liter millimeter mercury per mole, then K. So the temperature, of course, we are provided, which is 46 degrees Celsius, which has to be converted into Kelvin, which will be 319 Kelvin. Then the number of moles you don't know, but you can calculate the number of moles since you know what you are dealing with is chlorine, of course. So you know you have been given 92.4 grams of Cl2. It's existing in diatomic. So meaning you need to calculate. So you are saying 35.5 by 2. So of course you need to find the number of moles. So you are going to say 92.49 grams over 70.906 grams per mole. The grams will go, the number of moles, of course, you need to have 1.303 more, I think, yeah. So since you have gotten now the values, you have gotten the values, which is 1.303 more, you can now evaluate and get done with the question. Here they are looking at the volume. We are still under the ideal gas laws, which is a very simple topic, which just requires people to be playing around with the constants as well as knowing how to calculate the number of moles and the temperature conversions into kelvins. Then one will be done and be able to get correct values. So we substitute, we are saying 1.303 more. Then by the constant, of course, we are now in the millimeter mercury. So we need to use constant that relates accordingly so that we don't make any mistakes as regards our calculations. So you have that one, which is, then you substitute 319K divided by, what is the pressure given? We have been given 694 millimeter Hg. So of course our volume should be 37.4 liters. Then we are done. So that is the most important aspect. So that's the important aspect. Then we can go to question 17. Question 17, which is talking about the identification unknown gas. So question 17 now. So we are in a hurry and trying to solve as many questions. Most crucial questions that are posing challenges in tutorial sheet 5 as the latest tutorial currently in your hands. So we have you have been given the question on the krypton. So we are on question 17. So of course we know that rates. So we are talking about, you know, if the gas has got a smaller molecular mass, you know, it's bound to have that upper hand to move so fast. Even the distribution, if it had to be exposed in a room, it will occupy the room as fast as possible, as compared to one which has got a larger molecular mass. So you need to take note. So there is this formula which is rate A. So that is if you are dealing with two gases, which is equals to square root MB over MA. So this formula is very crucial as regards calculation. So we are saying that I'll give you some simple tips where we are saying if we say rate A is equals to this one they have given you, which is a rate for krypton. Krypton is found on the periodic table, which has got the chemical symbol of Kr, so you need to be observant as you look at it on the periodic table. So you have rate A over rate of Kr equals to 3.7, which has been given. Then there are a few things that you need to consider. You are saying A is the unknown. Of course, you need to know this gas, unknown gas, okay. Then B is the one which is known, which is krypton, okay. Krypton, okay. We can say it fuses slower, okay. So these are the simple first points that you need to know to be aware before you go further into your calculations, which will enable you to get what they want. So you need to consider what is happening. So these are the key points. Now we go into what they want. We substitute. So we are saying, I'll erase this part. Okay, I'll erase this part. And I'll remain with the other part. So now we have been told to say, so to further now calculate, you can just say square both sides. Okay, if you square both sides, you remember here we had something like 3.7, yeah? So when we square both sides, we're going to have 13.69 is equals to this one would disappear. Because we're simply saying half, I'm not trying to teach maths, then that will go. So meaning you just have 1. So now M for the krypton, then you're going to have MA, which we want, which is the unknown. So now rearranging. So you can say, of course we know the relative, the molecular relative atomic mass for krypton, which is 84.80 grams per mole, which is very easy. So we are able to determine MA for the unknown. So let's try to do it together. So we are saying we are at this level, we substitute. We know that M for the relative atomic mass for krypton is 84.80 grams per mole. Okay, we have that one. Now it's a matter of substitution. So we are going to say, if you want, you can work here. So you can just say MA 13.69, okay, equals to MKR, okay. Then you know, for MKR, you know, you say 84.80 grams per mole, okay. Then 13.69 cancel, which is MA. How much are we getting? It should give us 6.19 gram per mole. So you can identify the 6.19 gram. The periodic table should be able to give you the answer. Then lastly, which is question 18. Then we'll call it a day. So question 18. Question 18, what are they looking for? The total partial pressures, you know. There's also one way of finding partial pressure. So this question 18, is all about calculating of partial pressure. So they are looking for the total partial pressure. You know, when you are dealing with different gases, you are also required to calculate some sort of partial pressure. You know, there's a formula, so chemistry is also about formulas which has to be mastered and you know, known when and when not to use them, or when they are applicable or not. So you have been given different. You have been given the partial pressure for oxygen, which is 3.7 atmosphere. Okay. So you need to convert the partial pressures that are there. Then the pressures that they have given you pressures in different forms. You have those of the millimeter mercury. Then you have got kPascals, which is you need to convert them. So you need to show some conversion. So you have that of H2O. You have got 382 2 millimeter Hg, which can be converted as 382 millimeter Hg over 1 times 1 atmosphere. Of course, you need to know this 1 atmosphere is equal to 760 millimeter Hg. So this conversion should be kept by heart so that you are not referring it to, you are not having difficulties as to remember whatever has to be done. So this one, when you convert, this one should give you something like 0.5 atmosphere. Okay, 0.5 atmosphere. We can just say 0.50, okay, 0.5, it's okay. Then we go to, for carbon dioxide, which was also involved, we have 234 kPa, of course. Yeah, which can also be converted 234 kPa over 1 by 1 atmosphere over 101.3 kPa is equals to what? 2.3097 atmosphere. Okay, so you have got that one. Now you are remaining with the argon, which is PAR, which is equals to 143 millimeter mercury. Is equals to 143 millimeter Hg over 1 times 1 over 760 millimeter. So this one should give us how much? This one should give us 0.18815, okay, atmosphere. So once you have gathered, so our value, so once you have gathered, so we have now, if you have observed, we have solved for water, we have solved for carbon dioxide, we have also solved for argon. So now it's a matter of now adding. It's a matter of now adding, then it will be done for the day. So let's now add them. I'll try to add now, them so that you are able to get what is happening. So total P, so P total will be, so you are going to say P of what? Oxygen, partial pressure for oxygen, so partial pressure of water, plus partial pressure for carbon dioxide, so partial pressure even for argon. So our calculation was 3.7 atmosphere plus 0.50263 atmosphere plus 2.30997 atmosphere. So this one should give us a, how much? Should give us a 6.7 atmosphere, I'm sure. So then you'd have calculated. This is the answer for, this is question 18. So question 18. So yeah. So when you refer to that, then at least you'd have gotten the values. So just a word of encouragement, chemistry is easy. It's one course that people can score high grades as far as 90 something. It just calls for practice. It calls for revision, constantly checking through notes, because as you are moving forward, you're heading to the exam. So you need to ensure that you're constantly solving questions, asking questions, so that as you go in the exam this time around, for I know you're writing a test 2 next week, which is also part of the continuous assessment. You need to work hard. You need to ensure that at least you also try as much as possible to perform and produce results. This is where we end the session for CH111. So today we looked at tutorial sheet. We looked at part of the questions that you did in test 1. We revised a bit. We'll continue that revision next week. Then we also consider to solve some of the crucial questions that are in tutorial sheet 5, which I believe people are looking into it at the moment, which is the current tutorial. So from me, Mr. Mambwe, I say goodbye and sure that you are studying. God bless. Thank you.